There's still so many questions locked up in these rocks. It's exciting times just to be studying them.
So we have a big window, a big gap in our understanding of the early Earth, and the moon preserves that history.
Where did all of this stuff come from? How did it form? What was the process? Does it happen all the time across the universe? Or are we somehow unique or at least unusual? What does it all mean?
I'm Katie Atkinson, and this is NASA Explorers Apollo, where we tell stories about our moon and the people who explore it.
Tape recorder's running, right? Tape recorder's running.
When astronauts traveled to the moon, they explored its mysterious surface.
Look at that soil. It's all cake looking in it. Yeah, it is. Okay. Let me get the soil before you start whacking, okay? Oh, yeah. Very good.
They collected bits of soil, rock, and dust to bring back to Earth. And they were pretty excited about it.
Oh, hey, there is orange soil. Well, don't move it till I see it. It's all over. Orange. Don't move it till I see it.
Each sample was carefully harvested and preserved so that scientists of the future could learn more about the past. Inside of those samples, rich stories about the age of our moon and clues about its history. Natalie Curran is one of the keepers of these tiny, precious artifacts. She's been thinking about Apollo since she was a kid.
I think it was my uncle that brought me back. He went to Kennedy Space Center and he brought me a pack of postcards with all images from Apollo 11. They went all up around my wall when I was a child, and ever since I've always wanted to do something with space.
These days, Natalie calls herself a lazy astronaut. The moon rocks come to her instead of the other way around. Natalie is a NASA postdoctoral fellow and a planetary scientist who spends her days with Apollo samples.
I'm currently working in our MoonGrill lab, which stands for Mid-Atlantic Noble Gas Research Lab, which is here at NASA Goddard.
Natalie focuses specifically on samples from Apollo 16, which she looks at to learn more about the formation of the surface of our moon.
So a lot of the samples that we have, they're quite old. So they're some of the older rocks that you get on the moon. So we're looking at rocks that are older than 4 billion years old. Every time you look at something or think of something like that, what you've just analysed is older than anybody that we know, anything that we know is living. And that, again, is quite an amazing kind of achievement just in its own way to be holding and analysing these ancient rocks.
As it turns out, the moon can teach us a lot about the history of our solar system. Scientists like Natalie study lunar rocks, soil, dust, and sand. She and her fellow scientists weigh, measure, and scrutinize samples to find answers, and sometimes even more questions. The process teaches scientists about the makeup and evolution of our moon, but it also reveals plenty about our home planet.
Unlike the Earth, which we've had quite a complex history of plate tectonics where it's erased some of the surface, the moon hasn't had any plate tectonics like that. So the actual surface of the moon provides a perfect archive of both lunar history and solar history that we can go collect some different age samples and can tell us a lot about how the moon and the early solar system has evolved.
The moon goes farther back in our past than we can on the Earth. The Earth and the moon formed together at about the same time, 4.5 billion years ago. That's a really long time ago. But because we have water on the Earth and plate tectonics and a whole bunch of things that erase our surface and renew our surface, the rocks on the Earth don't go back farther than about 3 billion years. So we have a big window, a big gap in our understanding of the early Earth, and the moon preserves that history.
That's Barbara Cohen. She started and leads the MoonGrill Lab. Her team studies noble gases to learn more about the age of the lunar samples.
And those gases are interesting to us because they help us tell when that rock was made and how it was made and what processes it underwent. So we are trying to understand the geology of another planet through its rocks. and we use those gases to trace the processes that it went through on another planet. The element potassium decays over time to the element argon, which is a noble gas. And so we look at the ratio of potassium to argon in the rock, and we say how much potassium was there to begin with, and how much has decayed to the element argon over time. And that's a little clock inside the rock.
While scientists like Natalie and Barbara are interested in lunar and solar history, NASA's astrochemists, like Jamie L. Silla, want to know what these samples can tell them about the origins of life.
A lot of times what I'm doing is working in a lab with meteorites or other extraterrestrial samples, including the lunar soil samples that we've worked with. And I will take these samples, grind them up into a powder, seal them up in a vial with water, and heat them and basically make meteorite tea or lunar tea out of them. I'm pulling out the soluble compounds. And I try and understand how these chemical compounds formed and evolved and were distributed in the early solar system.
Okay. Let me get the soil before you start whacking, okay? Oh, yeah.
I'm very grateful for the scientists who had the foresight to archive these samples and for the curators who kept them all this time in a state that was ready for us to be able to look at.
It didn't, as a kid, seem like something spectacular to me. It was just part of history. But now when I get to handle these lunar samples in the lab and I stop and think about what it took to bring these back to Earth and where they've been and what the history of these samples is, sometimes I'm working in the lab and I just stop and I'm just overwhelmed by this amazement.
Each sample, carefully cultivated by lunar explorers, reveals more about the moon and planet Earth.
There's still so many questions locked up in these rocks that it's exciting times just to be studying them, yeah.
Barbara, Natalie, and Jamie will have the opportunity to keep learning about our moon very soon. They were recently selected to open up and study never-before-seen Apollo samples. Who knows what they'll uncover in the future? We asked you to help NASA tell the story of Apollo. Hundreds of people answered, from all over the world. Here's what Sophie, a 13-year-old from Greece, had to say.
Hi, I am 13 years old. I am from Greece and I live in Athens. I am very interested in space exploration and I would like to become an astrophysicist. Even though I was not born when the first humans walked on the moon, the Apollo program means a lot to me. The Apollo program and all the people who worked in order to make the impossible possible inspired me in a way that changed my whole life. Now, after having learned all these things about the Apollo mission, whenever I look at the moon, I dream about where the humankind is capable of going. When I think of the moon, I feel wonder and admiration because of the fact that humans have been there and because of the fact that this act has inspired hundreds of thousands of people, including me myself. Furthermore, whenever I think of the moon, I think that humans are now able, after so many years of space exploration, to make a step further of the moon to Mars and who knows, in few years, maybe even further to the interstellar space. I believe that the Apollo program made it clear that the sky isn't the limit.
What do you remember about Apollo? Or what space exploration do you hope to see in your lifetime? We want to hear your Apollo stories. Visit nasa.gov/Apollo stories to learn how to get involved.
Very good.
This is the only long-term information that we have from the surface of the moon.
I don't think the search for data is over with.
Where did all of this stuff come from? How did it form? What was the process? Does it happen all the time across the universe? Or are we somehow unique or at least unusual? What does it all mean?